Everybody, I don't think I can hear you yet though, because the system's still starting up. So give me 5 minutes.
Mic check. How's your day so far?
It's good. Yeah, just tired. I'm sure you guys probably know. You guys are probably more tired than I am. On Tuesday night, actually, after I left the lecture, I was driving home, and my I kind of ran over a curb, and my tire just completely blew out. The picture is pretty gnarly. Actually, let me see if I can pull it up here.
Want us to throw it up on Ansys?
I did that on the day of my sister or my stepsister's wedding.
Oh,
I blew out my tire. I was doing a U-turn on a street and hit the curb trying to pull into a car wash, and then I had to luckily, like, my mom lives local, so I called her and I borrowed her car to get to the wedding, and she rode back with the driver or whatever to get back to her place or whatever. It was insane. I didn't feel like I hit it that hard, but it was hard enough to where, yeah. Oh, good Lord.
Yeah, I felt the same way. Like I didn't. It felt like just a regular, like, run of the mill. I just kind of nicked the sidewalk, and then I started hearing like a and then I started seeing smoke, and I was like, all right, maybe I should pull over and see what happened. And then it's like, whoa,
Yeah.
my tire's not there anymore. Like, dang.
Mine blew out the whole sidewall of the tire, and
Oh,
so
man.
it was not something you could easily patch. You had to get a full replacement. It was crazy.
I see. Well, it's good you were able to make the wedding. That's always good. It always
Yeah.
happens at the worst times.
Yeah, that's odd. It doesn't even look worn out.
Yeah, it's okay. But yeah, it happened. I had to endure the because I was really hungry at that point, and so I didn't really want to change it myself, and so I called the AAA guy to do it for me, and I had to endure his looks of like, you fucking dumbass, and so. And I knew that if I tried to explain it, it would just make it worse, and so I just kind of said like, yeah, it happened. Please help me.
I mean, you must have hit the curb just at the right spot in order to get it to really collapse like it did.
Yeah.
But it's like,
I was definitely not paying. I could have been paying more attention though. So, I mean, it was definitely on me. But I have an appointment tomorrow to get it replaced, and so I'm driving on a spare right now. So if you see me on the road, please don't hit me because I'm driving on a spare tire.
Any plans for the weekend?
I'm gonna see 007 on Saturday with some friends.
Ah, nice.
Nice.
Nice. Taking advantage of that, well, if you have T-Mobile, that $4 movie ticket.
Yeah, that's exactly it. Actually,
Yeah.
my friend has that, and so
Nice.
yeah, we all bought tickets for that.
That's cool.
I forgot that was coming out.
Yeah, I didn't realize it either. Yeah, my friend asked me if I wanted to go. Which is cool because like I haven't really seen any trailers for it, and so I'm going in with really no expectations, and I feel like I enjoy the movies a lot better that way.
Oh, big time.
Because recently I saw the movie with Ryan Reynolds, Free Guy, and actually I didn't really know much about it either, but I ended up really enjoying it because I didn't come in with really any expectations.
Nice. I'm looking forward to Dune later this month.
Hmm.
Those are always the best ones when you don't know anything going into it. It's turns out to be so much better than you expected.
For sure. Yeah.
And I'm not trying to do it on this computer because I don't want the same thing that happened in that application will happen. You can't like get locked out of this kind of stuff.
I got a quick question. Will there be another activity after this? Or after this, are we expected to simply focus all of our time onto the midterm project?
Yeah. Right. So after this is going to be the last Ansys activity for a while. I do have more activities planned, but they're going to be later. And so, yeah, after this one, I want you to focus a lot on the project. And then the next Ansys activity is actually going to be not until week 12. And so we'll cross that bridge, much later on. I believe the topic for this activity is going to be transient simulation, which are dynamics. And so, yeah, after this one, just focus on the midterm project. We're going to have a midterm exam based on some of the topics we're going to go over for the next 3 weeks. And then we'll pick up new Ansys activities again after that.
Okay, cool.
Cross that bridge after we get done.
Yep.
Finite element analysis.
Yep. right, it's 5:30, so let's go ahead and get started. Good afternoon, everyone. How's everyone doing today? Hanging in there? I know it's busy times. I know everyone's kind of running on fumes right now, but I appreciate you guys coming out here because we do have hopefully a fun activity planned today. Okay. All right, and so the plan for today is we're just going to focus completely on activity 4. Okay. And so if you want to follow along in the class today, then now is the time to open up Workbench. Okay. Open up Workbench and then download the CAD file for the activity today, which you can find on the Canvas site. Okay. And so this activity is basically a follow-up to what we talked about on Tuesday, which is about shell and beam elements. And so what you're going to get a chance to do today is to see how to actually make shell and beam elements in Ansys and how to run a simulation on it. Okay. So this activity, there's quite a bit more to this activity than our previous ones. And so, I have to kind of do a little bit of a juggling act. And so I want to make sure I at least cover up to the point where you can kind of run simulations. But to get to that point is kind of a lot of steps. And so, I'm going to try to make sure I get at least, 85–90% of the people to that point. And then, for I think, just kind of naturally, just because these, what we're going to do here is not, it's not the easiest in the world, and it's a little bit annoying. And depending on how good you are with navigating in 3D and clicking stuff, that you might move faster than the other ones. And so if I do have to kind of move on and you're still stuck on a previous part, then don't panic. I'll come back to you later on and kind of help kind of individual people like that. But because there is quite a lot to do with the activity today, and so I want to make sure I get through most of it. And then also explain all the extra stuff that you have to do at the end as well. Okay, just because I want to make sure I put you guys off on a good foot, just so that you can do this activity at home or do the rest of it at home without too much confusion. Okay. And if you notice with the due date here, I push it back relative to what it usually is. And so usually I have the activities due the Friday after one week plus a Friday after we do it. But because there's a bit more in this activity, and I know that this is kind of the time of the semester where everyone gets really busy, I wanted to give you a few extra days to complete this activity. And so this will be due on Wednesday, October 20th, which is 13 days from now. And so it's almost 2 weeks. Okay. But you have to be careful because we do this class, we're about to go through quite a busy times in a few weeks, because we have activity 4, which is due week 9. The midterm project is due a week after that at the end of week 10. And then week 11, we have planned for the midterm exam. And so I just realized today kind of how busy that time is. And so I might push the midterm exam back a week just to kind of give you guys a little bit more breathing room. But we'll cross that bridge when we get there. And so I just want to make you aware that there's going to be a lot of stuff coming up in the next few weeks. And so I know the midterm project's not due for a few more weeks, but you should definitely if you haven't started it, I would start it, and then try to stay on top of it as much as you can. Okay. All right. So are there any questions I can answer before we get started with the activity today? Okay. All right. And so the activity today is called a bridge to new element possibilities. Okay. And basically what we're going to do is we're going to take this CAD model right here. Okay. And so I basically just took this model straight from GradCAD. And so credit to this user, whoever he is, for providing this CAD for us. Okay. And it's actually kind of the perfect example for this activity, because there's a lot of geometries here that we can turn into shells and beams. Okay. And so you'll see that there are a lot of slender geometries, a lot of thin geometries that will benefit a lot from transforming into shells and beams. But it's also not the cleanest geometry in the world. And so what you'll see is a lot of kind of the extra cleanup operations that you'll typically have to do when you're working with shells and beams in practice. Okay. All right. And so if you haven't already, go ahead and open up Ansys and then go ahead and import the model. Okay. So remember, the way that you do that is you right click on geometry here, and then you can import and then click on the bridge.igs. Okay. And, contrary to our previous activities, instead of spending most of our time in Ansys Mechanical, which is what we do for double clicking this, we're actually going to be spending a lot more time today in Spaceclaim, which is the CAD software that comes along with Ansys, okay? And so if you double click on geometry right here, even though there's a green check mark here, if you double click on geometry, it's going to open up Spaceclaim, because it should, at least because it's the default. But usually, just to make it sure, or just to make sure for me, I usually like to right click and then I click on edit geometry and Spaceclaim, okay? And it takes a little bit of time to start up. And so I'm gonna go ahead and start that process right now, okay? And so while that's starting up, and probably while it's starting up for you all too, I'm going to go ahead and run through basically what our plan for today is. Okay, and so our plan for today is we're going to take this geometry here, we're going to open it up in Spaceclaim, and then we're going to use the tools within Spaceclaim to basically convert as much of this into shells and beams as possible, and then use that as a basis to run our finite element simulation. Okay. And so kind of the new features that we're going to learn today is, how to modify a geometry in Spaceclaim, in terms of extracting beams and extracting shells, right? We're going to learn how to clean up the geometry in Spaceclaim, because that's going to be a significant part of today. Okay. And then what you'll see afterwards that, because of our cleanup operations, then Ansys is going to have some trouble, finding out where all the connections between the different parts are. And so we're going to learn how to create what's called manual connections in Ansys, to basically define for Ansys, how the different parts of the model should be interacting with each other, okay? All right. And so while I stalled, it looks like Spaceclaim opened up. And so was everyone able to open up Spaceclaim and see the following screen with their bridge geometry? Okay. All right, so I'm seeing quite a bit of nods. Okay. All right, and so kind of like what I was saying earlier, Spaceclaim is the CAD software that's bundled with Ansys, and so this is the one that they're kind of actively developing. And so up to this point, we've used Design Modeler, which is kind of their old CAD software, and so this is kind of the new one that they're using to advertise stuff. And so there's some features in this one that are a little bit nicer, but it's also a little bit more annoying in some ways. And so that's why I use Design Modeler for the other stuff. But for shells and beams, this actually makes Spaceclaim actually makes it pretty easy. Okay. All right. And so the first thing that we want to do when we get in here is we want to repair our geometry. Okay. Because what can happen sometimes is that if you're importing your CAD geometry from somewhere that someone else made, there might be some weird gaps or some weird nooks and crannies that within the CAD model that don't make it that are not conducive for finite elements. And so the nice thing about Spaceclaim is that it has quite a few automated repair features. Okay. And so within Spaceclaim, we're going to go to this tab right here called Repair. Why is it green now? Someone want to change it. And so we're going to go to this Repair button right here. Okay. And we're going to click on these two buttons right here called Stitch and Gaps. Okay. And so these two are basically automated tools within Spaceclaim that will help to kind of clean up some parts of the geometry that may not be good. Okay, and so for this model, there's actually nothing that this can find. But the reason I'm showing you this is that if you're going to be using Spaceclaim for other applications, this is always not a bad idea to do, because it's super fast, and a lot of times it finds some problem areas. And so the way they work is that you're going to click on a button here. And so let me start with Stitch. Okay. Right. And so after you click that button, Ansys is going to find or it's going to try to find some locations in the model where it can try to stitch things together. Okay. In this particular case, you can see that we have a notification here that says no areas found. Okay. But if it did find some areas, then this green check mark right here is going to light up. Right. So right now it's grayed out because it couldn't find anything. Okay. But if it did find something, then this green check mark would light up. You would just click it, and then Ansys would automatically fix those areas for you. Okay. All right. And so we're going to do the same thing with gaps. And so let's go ahead and click on gaps. Okay. And so after you click gaps, you can see that Spaceclaim was able to find one area. Okay. And so that area here is highlighted in red. Okay. And so to fix that area, you can go ahead and click on this green check mark. Okay. But usually that'll fix the any gaps it finds in the model. But for this particular model, and I haven't quite figured out why this is here or not. It's here on this side, but not on the other side. Okay. But for this particular model, it can't actually fix this gap. at least not with the automated tools. And so we'll fix this later when we get into mechanical, but for now, the automated system was not able to fix it. But normally when you click gaps and you click OK here, then it'll fix some gaps for you. But it's just for this particular case, it doesn't work. But you know, again, the reason I'm showing you this is so that, you know, when you're doing Spaceclaim stuff, you know, for your other applications, then you know, you kind of check for any kind of quick repairs that you can do. Okay? Yeah.
So would you fix those before making your elements, beam elements, or shell elements?
Yes. Yeah. Yeah. Because these are issues with the three-dimensional CAD geometry. Yeah. And so it's going to help you. Usually, it's going to help you with the shells and beams extractions as well. Yeah. Okay. Any questions on this so far? Okay. All right. And so the next thing that we're going to do is we're going to start to make shells. Okay. So let me actually get rid of this. Actually, no, forget it. Okay. And so to make shells, remember the operation that we used for this was called a mid-surface, right? And so the idea with the mid-surface is that we're going to identify two parallel faces within our model, okay? And then it's going to basically replace them with a shell, okay? And so for this particular geometry, we have three areas where we can add a shell, okay? And so I think the first obvious place is the road that's on the bottom, right? And so the road here looks like a very thin surface. And so that's a very clear, you know, a very kind of textbook place where we can insert a shell element, okay? And the other two places where we can put shells are actually going to be on the sides of the bridge, right? And so if you look at the sides of the bridge, you know, we have this, you know, kind of archway, but, you know, it's so thin in this dimension right here that, you know, it's going to be good to put a shell, okay? All right, and so to create a shell, we're going to go to this tab right here called Prepare, okay, at the very top of the screen. And then the tool for creating mid-surfaces is right here, okay? For some reason it grays out when I'm outside the window, okay? And so I'm going to click on mid-surface. And the way it works is that you simply just have to click both surfaces that are parallel to each other, okay? And so let me start with the side of the bridge, okay? And so I'm going to click on this surface right here, okay? And so after you click that surface, you'll see that it kind of disappears. And then what you're going to do after that is you're going to click on the other side, the parallel side, okay? And if both sides are sufficiently parallel and they're close enough, you'll see that they're going to be highlighted in blue and green, okay? And then once you do that, you can go ahead and click on this green check mark, okay? And then you can see that the mid-surface operation was created, right? And so the old three-dimensional object here is kind of grayed out now. It's kind of transparent. And then in its place, we have this kind of thin shell geometry here, okay? And if you want to get rid of the transparent ones, you can just kind of click anywhere within the window. And you can see now that instead of that three-dimensional object, we now have this kind of paper-thin shell element, okay? All right, so is everyone able to get a shell element from this from that side of the bridge? Okay, yeah.
I'm not getting it to select.
Oh.
Like I'm clicking on it, but it's not.
Did you activate the mid-surface operator here? Okay. Let me check real quick. And so for the rest of you, go ahead and create mid-surfaces for the other three. So go ahead and do it for the other side of the bridge and for the road as well. And so you should have three shells at the end of this. You'll go and then you need to click the other side. No, the other side of the same surface. And so you click on the inner side here, and then you're going to click on the outer.
Now that makes no sense.
Yeah.
I thought it was on either side.
Yeah. Because if you try to click those two, I think it says it's too far apart.
Okay.
Yep. Go ahead. Check mark.
Same thing.
Yep.
The other side.
Yep.
Thank you very much.
Yeah.
How would you deselect in case you accidentally select something?
Yeah, if you want to deselect, I think the easiest thing is just to choose a different tool up here. And so go ahead and click like volume extract and then come back to mid surface and then you can go ahead and click that again. Yeah. Yes, yes, do the road too. Yeah. So let me go ahead and do this really quick. All right. And so after creating your 3 shells, it should look like this. And so the nice thing is that after you create shells, then it kind of makes them transparent. And so that kind of helps to emphasize the fact that you have shells instead of solid parts. Okay. All right. So is everyone able to get the 3 shells here for the road and the 2 sides of the bridge? Okay. All right, great. Okay, and so that's shells. And so, mid surfacing is not too bad. As long as your geometry is kind of already thin enough, then it's simply just a matter of clicking the two sides. All right, and so the next thing that we're going to do is we're going to create beams. Move this out of the way. Okay. And so to make beams, we're going to go again into the Prepare tab. Okay. And then we're going to go into this section right here called Beams. Okay. You can see that there's a lot of tools in here, but the one that we're going to do specifically is this one called Extract. Okay. All right, so let me go ahead and close this, come back in here. And so if you highlight over the Extract tool, you can kind of read what its tooltip is. And so when you extract, you're basically extracting a beam from a solid. And so the solid has to have a constant cross section, but it can have tapered ends, notches, or cutouts in length. Okay. All right. And so I'm going to go ahead and click on this Extract tool. Okay. And then the way this works is that you simply just have to point your mouse at a beam geometry, okay, at a slender geometry, and then you just have to click. And so once you click, you can see that it replaces the beam with a line, okay. And so we're going to do that for the top supporting beam, and we're going to do that for all of the beams on the bottom as well. I don't know why I'm lagging like crazy. Okay. All right, so let's go ahead and extract all of these parts here. Okay. All right, and that made it lag less actually. All right, and then so and with that, we've successfully made shells and beams. All right, so is everyone able to extract the beams from the different parts of the bridge? Okay. All right, and so looks good, right? And so seems like we're done. Unfortunately, we're not. Okay, and so this is kind of where things get I would say more annoying than anything. All right, and so if you kind of zoom into the places where we extracted stuff, and so let's take this top beam for instance, okay? And so I'm trying to get it to an angle which kind of makes it more clear, okay? And so this top beam right here, its purpose is to kind of support this top part of the bridge to make sure that it doesn't kind of crumple in on itself, right? And so in order to do that, it has to successfully make contact with the bridge, okay, in order for it to support it. But you can see here by doing our mid surface and doing our beam extraction, you can see that we're no longer making contact here, right? And so we have this kind of little gap in between where the beam should end and where the side of the bridge should be, right? And so this isn't good because, if we take this into Ansys Mechanical right now and try to run a simulation, this beam is going to be kind of floating in no man's land because it's not attached to anything, right? It's really just floating in the air. And so we need to clean up this geometry in order to make sure that all the parts that should be connecting are still connecting, okay? All right, yeah.
If we went into repair and click on gaps, will it tell us that those gaps are there?
So we're going to use a different tool for that actually. And so we're going to use a tool that, because gaps is something that works strictly for 3-dimensional CAD models. And so this one is going to work for shells and beams. Yeah. All right. And so the next tool that we're going to use is going to be within Prepare here. Okay. And then the tool that we're going to use is called Extend. Okay. Right. But it's the same concept, and so but instead of gaps, it's called Extend. And so if you read the tooltip for Extend, you can see that this tool is going to extend surface edges or sketch curves up to intersecting bodies. Okay, and so this is going to help us kind of alleviate those gaps there. Okay. All right, so let's go ahead and click Extend. Okay. But unfortunately, after we click Extend, you can see that it didn't find any areas that we can extend to. Okay. And the reason for this is that right now, Ansys is only looking for gaps that are smaller than 10 millimeters, okay? And so if you look at the left side of the screen, you can see the settings for the extend tool there, okay? And so unfortunately, you know, the gaps that we have here are actually bigger than 10 millimeters. And so we need to increase that tolerance a bit, right? And so the tolerance that I used for this activity was 50 millimeters, okay? Right, and so after you change the tolerance to 50 millimeters, you can see that it's identified all these areas where, you know, the beams are not connecting where it should be, okay? And so the nice thing about this is that you can just go ahead and click the green check mark, okay? You might have to click it a couple times, okay? And so after you click it, you can see that it fixed not all of the beams, but some of the beams and made it intersect with the bridge, you know, as it should be, okay? All right. So is everyone able to extend the beams? Okay. Okay. All right. And so that worked for some of the beams, but it didn't work for all of the beams, right? And so I'm just to make it a little bit easier to see, I'm just gonna hide the road for a second. Okay. And so if you did your shells in the same order as me, then your road should be solid 3. Okay. And so I'm just gonna click on this check mark next to solid 3 right here, you know, just to kind of turn it off for now, because it'll make it a little bit easier to see. Okay. And so the road's still there. I just kind of hid it from view just so that, you know, we can see this a little bit better. Okay. All right. And so let's go ahead and look at some of the beams that are on the bottom. Okay. And then see which ones are connecting or not. Right. Okay. And so if we look at, let's say that this beam right here up top, right? So you can see that this beam was kind of successfully, you know, successfully extended to hit the bridge, okay? But this beam was not, right? And so if you look at this beam right here, we have a little bit of a gap in between the beam and the bridge, okay? And so this was not able to successfully extend. And so you might be wondering why that is, because it looks like it should be the same as the other ones. Okay? And the reason it couldn't extend is that it's not even within the plane of the bridge to begin with. Okay? And so I think that's kind of easiest to see if you go down to the XY axes here and click on Z. Okay, and so you click on the blue one. It'll kind of flip me around, but okay. And if we look at this beam right here, we kind of zoom in as much as possible, right? You can see that this beam is actually underneath the bridge, right? And so you can see here that there's actually a vertical gap between these two points right here, okay? And so when Ansys tried to extend, when we asked Ansys to extend these beams, right? Ansys tried to extend this as far as it could in this direction, but it wasn't able to find any intersecting solid. So it kind of just did nothing with this, okay? But that's not good because, you know, we still need this to intersect with this. Okay? And so we need to clean this up a little bit more. Okay. And the way we're going to do that is we're going to start. Let me zoom out a bit because I'm going crazy. Okay. We're going to move it vertically upwards. And so we're going to move it in the vertical Y direction just enough so that it's within the plane of the bridge. Okay. And then we're going to use the extend tool again in order to, you know, fully extend this to the sides of the bridge. Okay. Okay. So are there any questions on that? Does that make sense why we weren't able to extend this beam down here?
Quick question.
Yeah.
Are you saying that it's not connected to the lower part of the side? I don't know what you call that, but I guess the beams on the side.
Yeah, yeah.
That whole display.
Yeah, yeah. And so it's actually, the problem is that it's actually below it. And so it's, let me do this on Z again. Right? And so, you know, the problem with this and the reason why we couldn't extend this to the side of the bridge is that, you know, it's not even within line of the bridge edge itself. And so what we need to do is we need to move this beam upwards in Y direction such that it is actually, you know, within line with the bridge. And then we can successfully extend it. Yeah. Mm-hmm. All right. And so this step, and so this part is actually going to take place in a few different steps. And so the first thing we need to do is we need to measure how far off the beam is from the edge. Okay. And we're going to need to do this individually for all 4 of the beams that are still not connected yet. Okay. Because if you'll see when we measure them, so that the amount that they're off is different. Okay. So remember when I told you that this CAD model wasn't the cleanest thing in the world, and this is kind of a this is the reason for it. Okay. And so first thing we're gonna do is we're gonna measure basically the vertical Y distance that we're off, and then after we measure that, we're gonna move this beam upwards by that, basically the exact amount. Okay. All right, and so we're going to go into the measure tool right here, okay? And so this tool is going to let us measure different parts of the geometry, okay? And then specifically, you're going to click on this tool right here called measure, okay? All right. And so after you click on measure, then the kind of the options menu on the left is going to change. And then one thing that you need to highlight is you need to make sure that this option right here for show XYZ vectors is enabled, okay? Because all we want is we basically just want the vertical Y distance between the beam and the bottom of the bridge, okay? All right, and so the way this is going to work is that we're going to first click on the beam itself, okay? And so you can see here that you can see the length of the beam, and then you're going to hold Control with on your keyboard, okay? And then you're going to click on the bottom edge of the bridge, okay? And if you do that right, you should see, this window pop up here, which shows the Y distance between the beam and the bottom of the bridge. Okay. And so for this particular beam that I selected, then the distance between the two is 0.4127 millimeters. Right. And so if for you guys, if you chose a different beam to look at, then your distance might be different, but the one that I ended up picking was 0.4127. Okay. All right. So was everyone able to measure that distance? Okay. Okay. All right. And so now that we have this number here, let's go ahead and write it down. And so I have the gift of Zoom, and so I'm going to go ahead and just write it on the screen. Okay, but you can use your notebooks or whatever. Okay, and don't Sharpie onto your computer screens. Okay. All right, and so I'm going to click away just to make sure that we're deselected. Okay, and so from here we're going to go to design. Okay, actually let me clear these. Okay, we're going to go to design up here. Okay, and then the next tool that we're going to use here is called move. Okay, actually, let me go ahead and write the number again.
I think there might be a copy text option. I'm not sure if it's for the number, but
okay,
one appears on the cell.
Oh, nice. Yeah, if you want to use the copy text option, then that's definitely more convenient. Yeah. Okay, and so we're going to click on move right here. Okay, and so if you read the tooltip for move, this basically lets you select an object and you can move it or you can translate it, X, Y, Z in space. Okay, and so with the move tool selected, we're going to click on the beam, okay? And then after you click on the beam, you'll see that there's these several arrows and several, rotation things show up, okay? And so you're going to want to click on the blue arrow. So make sure you're clicking on the blue arrowhead, okay? And then after you click that, you can kind of click and drag, and you can kind of see that, you can move the beam up and down, okay? It's really hard to click and drag this to the exact number that you want. And so what I do is I kind of just click and drag it up a little bit, okay? Just to get this number thing to show up. And then I manually input the amount that I want to move it up by. Okay. And so it helps a little bit to round up, because we basically want to move this up enough until it intersects with the bridge. Okay. All right. Okay.
You said round up.
Yeah, round up, because we are usually the third decimal place is usually okay.
Okay.
Yeah, it doesn't have to be that precise, but try to make it as exact as you can. But make sure you round up, because we want to make sure that, remember, the reason we're doing this is we're moving it up enough so that this beam is intersecting with the bridge again, right? And so we want to be a little bit more rather than a little bit less.
Was your blue arrow, could it be different for everyone else on what color arrow we use?
from my experience, the blue arrow is almost always in the Y direction. But yeah, make sure you check that the arrow that you click is going in the positive Y direction. Yeah. Mhm. Okay. All right. So was everyone able to move the beam up by that amount?
Quick question.
All right, so I'm gonna do one more. I'm gonna do one more step, and then I'm gonna go walk around a little bit because I think this is the part where I usually start to lose people. Okay, and so now that we've moved the beam upwards, we can go ahead and extend it now. Okay, and so if you go back to the Prepare tab, and then you go to Extend right here. Okay. So remember before when we clicked this, it wasn't able to fix this beam because it couldn't extend it and it couldn't hit the bridge from the side. Okay, but now you'll see that when you click Extend, you can see that it found two areas, right? And those two areas are on the beam that we just moved up. Okay, and so we go ahead and click OK, okay. And so now our beam is successfully intersecting with the bridge. Okay. Yeah, so the amount that you measure, it depends on which beam that you selected. And so one of the beams I know is 1.9221 millimeters down. So I think you just selected a different one than I did. And so that's totally fine. And so you want to move that beam upwards 1.29221. Yeah. Yeah, so all the beams that are off right now, they're all off by a different amount. And so make sure that you're measuring for each of these beams, okay? And I'll give you guys about 10-15 minutes to kind of do the rest of the beams yourself. Okay. And so during this time, I'm going to walk around the classroom, and then if you're having trouble on Zoom, just drop a message in the chat and I'll help you out too. So if you have any issues, just raise your hand.
I tried it, but it's not extending, so there's nothing to extend still.
Okay, so let's kind of go from the beginning. So let's go to measure. Oh, it looks, yeah. All right, let's measure that one just to make sure. Let's go ahead and measure.
Oh, it's not. Oh, there.
You have to hold control. You have to. Oh, it's so close. You see, moved up just a smidge more. Design. Yeah. But be careful here because you're selecting both, and so go ahead and click out for a second. And now try to make sure you're selecting the entire beam. I had issues yesterday where people were kind of had both the beam and the bridge selected, and they kind of moved both at the same time. That was
That's that thing I was just doing right there.
yeah.
How do I do that?
You can go ahead and hit the undo button here. Question? Yeah. So the floor, I just hit it for now, and so I clicked on this check mark here. Yeah, we'll deal with the road in a bit, but for now, I just want everyone to make sure all the beams are connecting to the bridge. Yeah.
Do we need to do it to all the beams?
All the ones that aren't connected, and so there should be 4 beams that aren't connected right now. Yeah.
I don't know if it's just for me, but I think I have more except for the minimum.
Let me see. Did you hit the extend tool?
Like they're not exactly at the bottom.
Oh, that's that. It should be. Go ahead and rotate it.
Like,
Yeah, so that one we have to move up for. Can you see? me try doing that and extend. Okay, so it extended everything. So those ones that are inside it should be connected. Okay, this one. There should be 4 of them on the bottom. That one. And then 3 on the end. Yeah. Oh, nice. Yeah, control 8. That's good. For those of you that are, I'm gonna wait maybe about 3 or 4 more minutes for others, but if you're able to connect all the beams, you can go ahead and keep going with the PDF. And so the PDF has the instructions for the rest of this part. And so basically the part we're gonna do next together is we're going to basically do the same thing for the road. And so we need to move the road down a little bit just to make sure that it's within line with the bottom of the bridge. Okay. And so we're gonna move it down and then using the same measure operations as we did before. And then you're going to do an extend just to make sure that they make contact. Okay. And so you go ahead and start working on that if you've extended the beams.
Does it matter how high up you move the beams?
You want them to be all pretty close because in the end, because the next step once we get into mechanical is we're going to basically bond the road to all of the beams on the bottom. And so if they're not that level with each other, then it might not bond successfully. And so you want them to all be pretty close. I don't know what the exact tolerance is within Ansys, but they should be within at least 1 decimal, like at least 1.1 millimeter, I would say.
Oh, wow, okay.
Dr. Trent, you said we're moving the beam or the road surface to the height of the top of each of the beams that we just
Yeah.
extended.
Right, yeah, so yeah, we're gonna be moving the road downwards, just so that it's right on top of the beams, yeah. Yeah, I'll do it I'll give it 1 more minute, and then I'll do it together with everybody. Okay. All right, and so I'm gonna go ahead and move on to the next step, but if you're still working on the beams, then no worries, just kind of try to work at your own pace. And so I'm gonna leave some time at the end for me to kind of go and walk around and kind of help people. As this activity, I think, especially that I saw yesterday, is I think what's frustrating about this activity is, there's a lot of little actions that you have to do within Spaceclaim, and then moving things around with the mouse is also really annoying to do. And so if you're still working on it, then no worries, I'll come back to you in a bit. But I do want to make sure we kind of move on, because the part that comes after this can be a little bit confusing. Okay. And so just like I mentioned, the next step is to basically move the road downwards, okay? Because we want to make sure that the road, or the shell of the road, is basically sitting right on top of the beams, okay? And the main reason for this is that we're basically going to apply a contact region between the road and the beams to make sure that they kind of are bonded together, for the finite element simulation, okay? And so just like we did with the beams, we need to measure the vertical distance between the road and the beams itself, okay? And so we're gonna go back to measure here, okay? Make sure you have show XYZ vectors enabled, okay? And so I'm gonna click on the road, okay? And then I'm gonna hold control on my keyboard just like I did for the beams, okay? And then I'm going to click on the well, in my case, I clicked on the bottom edge of the bridge, okay? And so because that's what we want to line it up with, right? And so you can see here that the y distance that we need to travel is about 28.37, okay? Right. And so that's the vertical distance between them, okay? And so we're going to move this road downwards by this amount, but this one we're going to stop a little bit short, and so we want to round this one down. Because for this case, if we move the road too far down, so say we move it down 28.38, then the road is going to be suddenly underneath the bridge, which is not what we want. And so in this case, I'm going to only move it down 28.37. Okay. All right. And so let's go back into design here. Okay. Go ahead and click move. I'm going to click this entire road, and I'm going to move this downwards. Okay. I'm going to manually input the number, so 28.37, okay, right? And so if you're doing that, you can see that the road is now basically right on top of all the beams, okay? And then one last thing before we exit Spaceclaim is we want to extend, because right now, we can see there's this gap between the road and the bridge, okay? But the road and the bridge should also be connected to each other, okay? And so we're going to go back to prepare. And then I'm going to click on extend, okay? And you can see now that I've clicked extend, there are two new areas that Spaceclaim wants to extend, which are the sides of the road, okay? And so I'm going to go ahead and click OK, right? And after I click OK, you can see the road has been extended, right? And so now everything is touching that should be touching, right? And so we have all the beams touching the sides of the bridge. The road is on top of all the beams, all the supporting beams, and the road itself is connected with the side of the bridge as well, okay? And so by the end of the Spaceclaim part, you should have your, your bridge, your shell and beam bridge look something like this, okay? All right, so were some people able to get to this point where you have the road kind of extended outwards?
Doesn't matter if the road is like in between those bottom beams, like midway.
Yeah. So because especially for the beams that we didn't move up ourselves, those are kind of upwards a little bit. And so there's going to be a little bit of play between them, but they just have to be close enough. And so, you know, the next step is we're basically going to be bonding those surfaces together. And so, you know, at this point, they're all going to be close enough such that they do that. The road only acknowledges one point. Did you move down the entire road, or did you move down just one edge of the road? You want to make sure. Oh, and you might have accidentally moved up the bridge too, or moved down the bridge. And so, if you doing that, I would recommend that you hit the undo button here, because the move thing, like once you've kind of gotten rid of it, it's kind of hard to track what you're doing. And so I would hit undo until you get to a stable point, and then try to do the instructions over again. Yeah. All right. Okay, and so I'm going to go ahead and close out of Spaceclaim for now. Okay, and then we're going to open up Ansys Mechanical. But if you're still working on the Spaceclaim stuff, you know, don't worry, I'll come back around to you. But the next step is a little bit confusing, and I realized in the document I've hardly placed any images for this, and so this is the part I want to make sure I go over today. You know, even if you don't see it, even if you can't follow along live, then you'll have the video to kind of help you out, because it is a little bit confusing. All right, so I'm going to go ahead and close Spaceclaim. I said close Spaceclaim. Okay, thank you. Okay, and then now I'm going to go back to Workbench, and I'm going to double click on Model. Okay, and so this is going to bring up Ansys Mechanical, which is where we're going to apply the meshing and the boundary conditions. Okay.
Hey, Professor?
Yeah.
Could you have all this open ahead of time and then edit one or edit the other, or do you have to open it fresh?
I think it's best to open it fresh, because when you open up a new program, that's when it loads data from upstream. So I don't think they update each other in real time. Yeah. And if they did, I think it would slow down your computer pretty massively too, because it's trying to run so many programs at the same time. Yeah. I've never tried it though, and so if you want to try it and let me know how it goes, then. But that's kind of just how I understood it from before. Yeah. Oh, I see. I see. Okay. All right, and so here we are in Ansys Mechanical, and so this is the interface that we've used before. Okay, and so first thing we're going to do is we're going to get rid of this weird twig chopstick thing here that I still don't know what this is. Okay, and so if you look at this at the geometry subtree here, you can see that it's the only part with the question mark. Okay. And so we're just going to suppress it, because we don't need it in this simulation. And so let's go ahead and right click this and hit suppress. Okay. And then now our geometry is happy. Okay. All right. And so from here you can see that, you know, we have quite a few parts in this assembly, and so, you know, way more than our signposts from before, right? And so we have 3 shells here and then 8 beams. Yeah.
Which part did you suppress again?
This one called sys/surface. Yeah, it should be the only one with the question mark next to it. Right, and so we have 11 different parts of the geometry, which is a lot. Okay, and so usually at this point you can start to go into mesh and apply your boundary conditions. Okay, but we have one problem here. Okay, and the problem is here with the connections. And so normally when you have a multi-part assembly like this, then Ansys should be able to create the connections that determine how the parts interact with each other. Right? The unfortunate thing is, because we modify this geometry quite a bit by turning it into shells and beams, then none of the connections here were auto-generated. Okay, and so we basically need to define these connections ourselves. Right? And so, you know, that's what I'm going to spend probably the next 10 minutes doing. Okay, and so go ahead and right-click on connections. Okay, and then you're going to go to Insert, and then you're going to click on Manual Contact Region. Okay. And so what this will do is this will basically have you select 2 different geometry types here, okay, or 2 different parts of the assembly that you want to bond together, okay. And so one of them is called the target, and the other one is called the contact, right? All right, and so let's think about, you know, which parts of this geometry should be bonded together, right? And so first thing we should see, or first thing we should note, is that the sides of the bridge, and so this guy right here, okay, this side of the bridge should be bonded or should be welded with all the beams that are connecting to it, right? And so we need to make sure that we define that region. So let's go ahead and do that first, okay? And so I'm going to go ahead and select all 8 sides of the beams, okay? And so you want to make sure that you're in vertex selection mode right here, okay? And so with that selected, we're going to go ahead and select all the sides of the beam, okay? And so you're going to mouse over each of the parts until they turn green, okay? And make sure you're holding down Control on your keyboard to make sure you can select multiple at the same time, okay? Right. And so in the end, you should have 8 of these selected, so 1 on top and then 7 on the bottom, okay? And so with all 8 selected, you're going to go to the bottom left of the screen, okay? And then you're going to go to Contact, and then you're going to hit Apply right here, okay? And so by clicking Apply, you know, you're going to specify that part of the contact. Okay. All right, and so that's the that defines that contact. Okay, and now we need to define what parts or what part of the assembly that these beams should be connecting to. Okay, and so for this model, they're going to be connecting to this side of the bridge. Okay, and so this side of the bridge here is a surface, and so you want to make sure you have the face selecting mode highlighted. Okay, okay, and then you're going to click on the target. Okay, and you're going to hit Apply. And then you're going to define that contact region just like that. Okay.
Can you say that again?
Yeah. And so for the target, you're going to make sure you're on face selecting mode right here. And then you're going to click on the side of the bridge which they're going to be connected to. And then you're going to, once with that selected in green, you're going to go down to target right here on the kind of in the details menu. You're going to click on that, and then you're going to hit Apply. And then once you've applied that, then this contact is fully specified. And so what this contact is saying is that these 8 vertices, or these 8 parts of the beam, they're going to be bonded together with this side of the bridge right here. Okay. All right. Was everyone able, or everyone that's at this point, was everyone able to bond those 2 things together? Okay. So let's do the same thing on the other side. Right? And so let's go ahead and right click on contacts here. And we're going to insert another manual contact region. Okay. Oh, question from the chat. How do we know if it was successful or not? And so if it was successful, if you look at the bonded support that you just made, there should be a green check mark here, right? And so that means it's fully specified. And then if you look at these 2 windows here on the side, that'll show you kind of the 2 regions that you're bonding together. And so on one window, you should see your 8 beams. And in particular, you should see that the ends of the beams are going to be highlighted with a white square. Okay. And then in the other window, you're going to see the part that is bonded to, which is the side of the bridge.
Dr. Trent, does it make any difference which one we're just choosing as target and which one as the contact?
It does actually, yes. And so you know, the explanation why it does, I think is a little bit too long for this class, but I think we'll talk about it later. But basically, the logic that you want to use is that the target should be the bigger face, okay? And so whichever one is bigger between the 2 things you're bonding together, that should be the target, and then the one that's smaller should be the contact. And so in this case, you know, because the side of the bridge here is much bigger. You want to choose that one as the target. And then since the other thing is just a bunch of vertices, you'll choose that as the contact. Yeah. So it does matter. And so if you pick them in the reverse order, then actually Ansys won't be happy with that. And it'll say that it doesn't know what to do.
Got it. Thanks.
Yep.
Quick question.
Yep.
I think I noticed on the Spaceclaim, in that same section where the extend was, there was one called welding. Would that have helped the contacts or the connections here?
Yeah, I'm not sure. I haven't experimented with that feature yet, and so it might. You know, I just haven't experimented. So this is just kind of how I've learned it in the past. But yeah, maybe doing that welding tool will improve the contacts. Yeah. You're highlighting the outer face. And so the nice thing about, the shells thing is that there's only one side of this. And so it looks like there's two sides, but remember it's a 2D thing now. And so if you select kind of one side of this, it's going to select the other side as well. Yeah. Let me go ahead and do the rest of it just because we are running a little bit short on time. And then I'll kind of double back with everyone else. All right, so we're going to do the same thing on the other side. Okay. And so just like I did on that side, I'm going to go ahead and select all these vertices here. Okay. Oops. Okay. All right, and so there's our 8 vertices, and then we're going to select the other side of the bridge. Okay. Go ahead, hit apply for that. Okay, and so that's our next contact region. Okay, and so we have 3 more contacts that we need to define. And so we need to define, we need to make sure that the road is connected to all the beams. Okay, and so I'm going to go ahead and insert another manual contact region. Okay, let me go ahead and select the road. Okay, and since that's the bigger surface, I'm going to specify that as the target. Okay. And then I want to make sure the road is actually fused with all the supporting beams. And so I'm going to make sure I'm on edge selecting mode here. Okay. And I'm going to select the 7 beams that are on the bottom.
I'm assuming for the road, it shows the whole body.
Yes. Yeah. Mm-hmm. Okay. And so the road is now bonded together with the beams on the bottom. Okay. And so we have 2 more that we need to do. And so we need to make sure, and so the last things that we need to make sure is we need to make sure that the road is bonded with the side of the bridge. Okay. So I'm gonna go ahead and insert another manual contact region. Okay. And so I'm gonna go ahead and select the side of the bridge. Okay. So that's going to be our target. Okay. And then for the contact, you have to be a little bit careful here because, because we lined up the road with the bottom edge of the bridge so well, then it can be a little bit hard to select the edge of just the road itself. And so what I usually do is that, if you notice from the geometry, one side of the road is actually hanging over the bridge by a little bit. Okay. Right. And so you want to go onto this side and you want to click on just this region of the road right here. Okay. We're going to go ahead and hit apply. Okay. And then we're going to do the same on the other side. Okay. So we're going to go right click, insert, manual contact. Go ahead and select this side of the road. Again. Okay. And then I'm going to select the side of the bridge that it connects to. Okay. All right. And so in the end, you should have 5 different contact regions. Okay. And so 2 for the left side of the bridge. And so 1 that connects the beams to the left side of the bridge, and then 1 that connects the road to the left side. 2 on the right side of the bridge. And so 1 that connects the beams to the right side of the bridge, and 1 that connects the road to the right side of the bridge. Okay. And then 1 other contact region that connects the road to all the beams on the bottom. Okay. All right. And so the end of the class kind of snuck up on me as a little bit, but I do want to give you guys a few minutes to kind of finish this up. And if you're having any trouble, go ahead and raise your hand, and I'll come by and help you. Okay.
What were the other 3 contacts?
You're going to do another 2 on the other side of the bridge, and so you're going to connect the beams to the side of the bridge and the road to the other side of the bridge. And then the last one is connecting the road itself, and so the entire surface of the road to all the beams on the bottom. Okay. Mm-hmm. Okay. Yeah, Chris, I'll double back with you after the class, but yeah, I want to make sure that we get past this part for the rest of the class, and then yeah. So the extension can be kind of annoying too, and so that's kind of where I usually lose people.
For the side of the road, did you choose the target to be the side columns or the side? I'm not sure what's that.
Yeah. The side of the bridge. I chose that to be the target because it's bigger than the edge. Yeah. Mm-hmm.
We should have 5 bonded.
Exactly. Yep. Yep. If you did all the contacts, you should have 5 bonded sections here. Yep. Mhm. All right, one more minute and then one more minute and I'll kind of give a quick preview of the rest of the assignment because there is quite a bit more. But this is the hardest part by far. And so from here it's pretty standard. And the nice thing about this is because we're doing shells and beams that the cost of the simulation is pretty low. But I want to make sure I kind of get through everything here before we move on. Yeah. Sure, third contact. Mhm.
Dr. Tran, it should automatically check mark when you have the edge and the.
Say again?
It should automatically give you a check mark when you've successfully bonded those.
Exactly. Yep. Mhm. If it's not check marked, then you might have to switch the target and the contact. And so you can do that easily. And so if you're not getting a green check mark, you can right click on the contact here, and then there's a button called flip contact and target. And so you can just go ahead and click that, and then it'll flip the two. And if that doesn't fix it, then let me know.
That works.
All right, I'll give it one more minute, and then we'll give kind of a quick preview of the rest of the activity. Yep. Yep.
So I'm excluding half this, which is the right.
Yep.
Left.
Yep.
And then just the base to force method.
There should be 5, and so you should also be connecting the sides of the roads, and so the left, like basically the edge of this road right here, to the side of the bridge.
Oh, okay.
Yeah.
So
So
on both sides, okay.
exactly. Yeah. And so that would be.
Does it matter if I click connection to do it versus just going right here?
It shouldn't. It just makes it a little more clean.
Yeah, it looks
so. Yeah.
Okay.
But it should do it all the same.
Okay, thank you. When you do the road to the side of the bridge, what's your target contact?
So the target's going to be the side of the bridge, because that's going to be the entire surface, and then the contact should just be the edge of the road. Because
Okay, got you. Thank you.
Okay. So we have 10 minutes left, and so I want to make sure I give a preview of the rest of the assignment. Okay. And so if you're still working on the contacts or you're still in Spaceclaim, then just kind of just watch for the next 10 minutes. I'll stick around after class. I can stick around until maybe 7, a little bit after 7, to kind of help people out. But I want to make sure I show this stuff to you. Okay. And so from here, it's a pretty standard finite element analysis. And so we're going to put a mesh on this. Okay. But I do want to show you something with the mesh, because this next part kind of panics people a little bit. Because if you're running with the default settings in Ansys right now, after you mesh, you might get something that looks like this. And I think when most people see this, they kind of panic and they say that, I thought I changed this to shells and beams, so why is it making all this blocky stuff? I thought we wanted to get rid of this. And so there's a setting for this. And so if you go up to display, okay, and you can see there's a setting here called thick shells and beams. And so it's just a rendering thing that Ansys does to to make it seem like you have kind of thicker elements than you have. Right? And the reason it has this as a setting is that oftentimes, for this model, we converted everything to shells and beams. But for other geometries, you might only convert part of the geometry to shells and beams. And so with this makes the mesh looks like it's consistent with the other parts of the model, but they actually are shell and beam elements. You just have to turn off this option right here. Okay. All right. And so the next part after that is applying boundary conditions. Okay. And so I've basically told you to constrain the bridge in 2 locations. And so one's going to be on one side of the bridge and the other is going to be on the other side. Okay. And so those are your constraints. And then you have to apply some kind of loading. Okay. And so I'm going to leave it up to you guys to decide what kind of load that you want to put. Right. And so there's a lot of options here. But if you want to recreate my results that I have here, then what I did was I put basically a constant pressure on top of the road. Okay. I don't remember the magnitude that I put onto it, just because I created this activity a long time ago, and I wasn't able to recreate these numbers. But these results should kind of give you a sense of what you can expect from the visuals of the results. Okay, and so if you want to recreate these same visual patterns, the way I did this was I just put a constant pressure on top. Okay. Okay. And so problem 4 here is analysis results. And so you're going to basically, show the screenshots as you typically do. Okay. And again, your results might be different than mine if you chose different boundary conditions, but here are just some references for you, just because I know this was kind of a long activity and there's a lot going on. So I wanted to give you a reference point for what the solution should look like. Okay. All right, problem 5. And so for problem 5, I'm going to make this one optional for this class just because it's, I'm making my grad students do this, but for you guys, it's optional. Okay. And so problem 5 is something called a mesh convergence test. Okay. And so a mesh convergence test is basically a way to measure how accurate your mesh is. Okay. And the way it works is that you're basically going to run your simulation with the same boundary conditions. Okay? So that part's really important. And so with the same boundary conditions, you're going to run several different simulations with different mesh densities. Okay. And so basically usually you start with a coarse mesh, and so you start with the mesh with a relatively few number of elements with a large size. And then you successfully kind of refine that mesh. Okay. And so you make the mesh size smaller and smaller and smaller. Okay. And then throughout that period, you should see your solution, change, because, as you change your mesh, your solution is getting more accurate. And then after a certain point, your solution should not really be changing all that much. And so you kind of reach the state of convergence, right? And so this right here is kind of the goal for every single mesh, that you kind of reach the point where further improvements of the mesh are not going to make any difference, right? And so for this assignment, if you want to get 10 points extra credit, you can do a mesh convergence test, and you're going to need to do it with at least 10 different mesh sizes, okay? And so what I'm showing you here is a mesh convergence test for the deformation, okay? But for this problem, I want you to do it with the equivalent stress, okay? And so you're going to run 10 different simulations, 10 different simulations with 10 different mesh sizes, okay? And then you're going to track, what the maximum equivalent stress is for each of those simulations, and then plot it in Excel, okay? And what you should see is that eventually, once you reach a certain point, then your convergence graph should level out just like this. Right, but again, this problem is going to be optional for you guys. Okay? All right, problem 6. So problem 6 is I want you to change the supports conditions. Okay, and so because in the default settings, I'm having you just support it on the 2 ends. Okay, but for problem 6, I want you to add some additional displacement supports at all the locations here that I've indicated in green. Okay. Because typically, you know, when you have a bridge like this, there's also supporting columns on the bottom. Okay, and so these locations are going to be kind of to basically emulate that. Okay. All right, and so this one's pretty straightforward, and so I just want you to rerun your simulation, but with some additional supports. Okay. Problem 7. Problem 7, I want you to rerun the simulation, but with solid elements. Okay. And so I think the easiest way to do this is just to create a whole new project, reload your bridge geometry, and then just run the simulation on that without converting anything to shells and beams. Okay. And so, you know, I want you to rerun that simulation and, you know, show me the results of the deformation in the stress field. Okay. And then problem 8 is the last one. And so problem 8 is just to summarize your findings. Okay. So same as we usually do. All right. Okay. Any final questions on the activity before I kind of go around and just kind of help catch people up?
Yeah, quick question. By doing the shells and beams, since we're moving around the different, I guess,
Yeah.
Are we changing the geometry of our actual solid?
That's a great question. Yeah. And so technically you are. And so, you know, because we are moving stuff around, we are changing the geometry. But it's kind of it's a little bit of a necessary evil that we need to do in order to make it work with shells and beams. And so ideally, when you modify the geometry, it shouldn't be too much, and you should be trying to and the goal with the modifications is to try to make it consistent with how the original geometry was. Because just naturally by doing shells and beams, you're going to be, you know, making things thinner and making things not connect. And so all the modifications that we did today was to make sure that things still connected as they should. But yeah, things are moving around, and so, you know, that does change to the geometry, and so that's definitely something good to keep in mind. Yep. All right. Any other questions? Okay, and so that's the end of kind of the activity. And so if you're still working on some of the other parts, just let me know. I can stick around till about 7 today, and so and maybe I can stay a little bit after that. And so, you know, I want to make sure that I get as many people past the connections part as possible. But if you're past the connections part and you're already running simulations, I think you're in great shape for the rest of the activity. Okay. All right. So thank you everyone for tuning in today. I hope everyone has a great weekend, and I'll see you next Tuesday. All right. If you're still having issues, just let me know either through the chat, or if you're in the classroom, just raise your hand and I'll come around. Chris, you said you were still having some issues, right?
Yeah, I was trying to get my my road to extend, but it just wouldn't for some reason. Not
Okay.
sure why. I tried fiddling around just now and it wouldn't allow it. I
Okay.
even stretched the road above and then simply remeasured it again to get that proper balance, but it still won't allow me. I don't know why.
Were you able to get all the beams to connect?
Yeah, all my beams are connected.
Okay.
I just noticed that one of them's a little above. Could that be the catalyst to my problem?
It shouldn't be, at least not with the road, because the road is only going to be measuring the road relative to the sides of the bridge.
Mm-hmm.
So let's measure it one more time. And so let's go ahead and measure the or you can rotate it actually, and so it might actually be better so that if you rotate it, yeah. Okay, so let's go ahead and hit the measure tool. And so go to, yep. So go ahead and hit, go ahead and click the entire road. And then hold control, and then let's hit the bottom of the bridge. Yep. Oh, it's all zeros.
Yeah.
Okay. All right. And so let's go to prepare again. And then let me see, extend. Is that 50? I can't tell on the left side.
Oh, it's not. It's at 10.
Okay.
Oh my God.
Yeah, let's try this now.
That's gotta be it then.
All right, hit enter.
Oh.
I think you have to hit enter on the 50 mil. 50.
Yeah, I did.
Oh.
Let me
Still
try it
nothing, huh?
Maybe 100?
Yeah, you can try it. Still nothing, huh? Oh.
That is odd.
That's really weird. Oh, strange. Can you hit some undos on the and let's get to the point before you move the road down to begin with. Let's keep hitting undo. I want to get to the point before the road was moved down.
Okay. That's all my undos. I had to close it and.
Oh, okay.
Yeah.
Oh, I see.
I can try before I attempted that big move from before.
Yeah. If you can get to that point, that'd be good. Jasmine, so for the meshing, actually for this one, I know in the activity document I said to create method and sizing objects, but you don't have to do that for this one. And so you can just use the global meshing settings for this. Actually, it might make it a little bit easier just to control the size and to control the order from there. Yeah, Chris, try to get back to the point when you kind of before you made that big move, and then we'll go from there. Let me check to see if there's anyone in the class.
I think I might have to do this from scratch. Let me attempt that again.
Okay.
Going back to the meshing, so don't include the method mesh.
Yeah, so for this one you don't have to, and so you can just do the settings from here. And so if you just click on mesh right here, you can just change this element order here to quadratic, and then you can change the element size to whatever. So let me change the units to mm. It's a little bit easier. So let's do a size of, I think in the end I use 20 mm. Yep. And so this is going to change the settings for the entire mesh. And so in theory, you should be changing each part individually. But there's so much going on with this activity that I think this just makes it a little bit easier. Yeah. Oh yeah, okay. Let me show so Jasmine can see. Right, and so for the mesh, basically, normally you create mesh method and mesh sizing objects here, but for this activity, I think it's a little bit easier just to click on mesh right here, and then changing these two settings right here. And so these are the meshing settings that I used, and so that produces this mesh right here. And so you want to make sure that you're quadratic, just because we are doing a structural simulation, and then the size should be around 20 mm. Yep. That question. So when I say add displacement support, do we add connections from the support endpoints? So the displacement supports are actually boundary conditions, and so those aren't additional contacts. And so what I mean by that is you're going to insert a displacement here, right? And so then you're going to select these eight places. Okay. And so we're not connecting this to anything new. We're just providing it some additional support. And so you're going to make it so that the y displacement there is 0.
Yes.
Yeah.
Sorry, just kind of to add on to that, is that just because we would probably expect it to be moving in the other direction?
We do it like that just to for stability reasons, and so if we kind of fix it in too many, actually it should be okay. And so I think the only reason I did that is just to kind of give the bridge of flexibility, kind of expand and contract a little bit. But if you actually do it with fixed conditions, it should be fine too. And so you can either do a fixed support or a displacement. I think they should both give you the same effects. Yeah. Yeah. Mm-hmm. Thanks, you too. Yeah.
When you say workbench, that saves everything you're doing in the can.
Yeah.
and all that, right?
Yeah, and so it saves everything there. But if you're moving it between computers, I recommend that you actually do archive. Because if you just do a save from Workbench, it'll save multiple files, and then it makes it really complicated because it saves like the file paths and everything. And so if you click archive here, then it actually saves it as a single file. It's going to be like it's going to be a zipped folder basically, but that's
I've been bringing a flash drive around, but I'll spend the archive.
oh yeah. And so with archive, you can like email it to yourself, and it'll be fine.
That'll come in handy for using the bridge as a base. Yeah, the first.
Yeah. Yeah.
Thank you very much.
Yep. Mhm.
That's a different audience.
Dr. Tran,
Yep.
your for your forces that you added onto it, one end is a fixed constraint, the other end's a displacement
Correct. Yep.
that has a 0 in the y component.
Exactly. Yeah. Mhm.
Okay. And then you said for your forces, I was going to put just like a distributed load across the whole top surface.
Yep. That's perfect. That's exactly what I did.
Would that be just a pressure force or just a force?
You can do either, and so it depends on what units that you want to put the force in. And so I think for my own results, I just did a pressure, just because I think I was just testing stuff out. But I think a force would actually make a bit more sense, just because you can imagine, this bridge is supporting like a bunch of cars and a bunch of people, and so you can just measure just the weight of everything, and then just apply that as a force boundary condition. Yeah, but they both should do basically the same thing. It's just different.
So I could say that it's going to be like 5,000 pounds or something like that.
Not that much. And so actually, if you look at the dimensions of this bridge, it's actually a bridge for ants. And so the dimension of the bridge is actually really small. And so 5,000 pounds might cause the whole bridge to wilt. So
it was warping a lot. So
Yeah.
that's why I was like,
yeah, I think the entire length of the bridge is only like 3 meters or something like that. So yeah. Yeah, about 3 meters. Actually, we can look at the bounding box. Let's see. Yeah, 2.5 meters. And so it's a bridge for ants. Or a bridge for cats. I think that might be more accurate. Yeah. Good. How's it going? Studying?
Yeah,
When is it again? Next Tuesday?
yeah, it's on Tuesday, so I kind of just have to put off all this until then. And then jump on this and the project.
Hmm.
As much as I wanted to start off the project as early as possible, I know the brainstorming that, but the actual like, getting the project and all of that is cut 17 in half and have to start it up like that stuff.
That's a good start. I mean, the parts that are going to take the longest are going to be the brainstorming and the writing for this.
Right, I'm
project.
trying to write it up as I go. so
Yeah,
I don't have to
that's a smart
front
idea.
back.
Yeah, that's
So I
a
kinda
good
start with
idea.
The abstract and stuff,
Mhm.
and stuff I can do, and then while I do all the analysis, and the boundary conditions dimensions.
That sounds good.
So, remember.
No, it's a good plan.
They won't give me a weekend access to this room.
Oh, really? Oh,
Yeah, I obviously got the after hours pass, but it's only valid on the weekdays,
oh, I see.
and I'm already here on the weekdays.
Hmm.
So like, it's gonna be hard for me to promote it from home. And do,
Yeah.
Ansys, but they said they'd let me know.
Okay. Yeah, keep me updated too on what they
Yeah.
say.
Okay, I just did it from scratch. I am now at the stage where I am to connect my
Okay,
My
yeah, let
road?
me, go ahead. I'll watch and if there's anything, I'll say something.
Thanks, Dr. Tran. Have a good weekend.
Thanks, you too. See you, Stephen. Okay. Yeah, it should be about 28.37. So the amount that I moved it down is about 28.37 because you don't want to move it too much because it's going to go below the bridge. And so we want to make sure that it's still within contact of the bridge. Yeah. Go ahead and click away for a second just to make sure that, yeah. Okay, so now let's try moving the road downwards. Okay. I think you moved it down a little bit too much. And so if you can move it up just like a smidge, just like maybe 0.001, 0.001 millimeters, and I think you should be good. Yep, perfect. Okay, so let's try the extend one more time. There you go. Perfect.
Wow, that is very finicky. All
Yeah,
right,
it's
cool.
really finicky. Yeah. Yeah, for this, for when you're moving the road down, if you move it down a bit too much, then it actually moves it below everything. And then you run into the same problem as you had with the beams before, where it just has nothing to connect to. And so you have to kind of do it just kind of exactly right there.
Okay. Okay, perfect.
Okay, all right, yes, should be good to go.
Okay, cool. Thank you again. I wasn't supposed to do any type of connections to the road from on this stage, right?
No, so you do that in Ansys Mechanical.
Right. Okay. All right.
Yeah, so
Awesome.
the recording will be up. I'll try to post it tonight when I go home, just so that you can kind of watch that because it's a lot easier to watch and rather than kind of read it from the instructions. But yeah, go ahead and get some dinner for yourself. You know, relax a bit, and then I'll have the video up by later tonight.
All right, sure thing. Thank you very much. Really appreciate it. Enjoy your weekend.
You too. See you, Chris.